Hello and welcome to Game Titan. Today I wanted to explore this idea of a fractal tree. I was looking at this math construction that comes up pretty frequently in math called the Sierpinski Triangle. And the way that you normally think about constructing it is to start with a triangle and cut out a triangle in the middle of that, which leaves you with 3 triangles, and out of each of those 3 triangles you cut out a triangle from the middle of that, and that leaves you with 9, and you cut out a triangle out of each of those 9, leaving you with now 27, and you keep going until you end up with something that is very intricate and complicated like this. And as you keep zooming in on any part of this triangle, it ends up looking like the original looked. But as I was looking through this page for more information about how to construct it, I came across this animation which shows that you should be able to construct it by creating a fractal tree and changing the angles that these lines are being displayed at. So what's happening here is that you start with a single line, and then you convert that into 3 lines, which are some angle apart from each other, and then out of each of those 3 lines, what it looks like happens next is you have a shorter version of that's coming out, and then out of each of those you have 3 more coming out, etc., etc. And as you change the angles, this diagram is claiming that you could potentially get effectively the Sierpinski triangle if you set these angles to be 120 degrees apart, so that they're pointing in 3 kind of as far apart directions as they could be. And my hope is that this is actually not too difficult to build in Scratch, and I wanted to try it out. So this is going to most likely require the pen block, is what I'm thinking. And you can find the pen block by clicking on this blue icon here with the plus sign and these block shapes called Add Extension in the bottom left. And here there's a bunch of things like music and video and Google Translate, but one of the extensions that you can add is the pen block, which allows you to draw with your sprites. In this case I don't have a sprite, I just have the stage, so that's why many of the blocks are missing. So let's add a sprite back in, and I don't think that it really matters which sprite that we pick. So we could potentially just pick the cat. I have in the past picked the pencil, it looks like it's drawing. Although, oddly enough, the pencil is not actually set up to be pointing at the center of the sprite, so you actually need to change it like this so that it's actually pointing at the middle if you want it to look like it's actually drawing. I'm not sure exactly why it's built that way. But in any case, there we have it. And what we can do with these pen blocks, which you can now see all of now that we have a sprite selected, is there's pen up and pen down. If you've ever used Logo, which is a program or another programming language that uses a turtle, I think some of the robots that are out there have a similar thing. You can imagine that your sprite has a pen in it that can either be put down on a piece of paper or pulled up, and that's what these 2 blocks do, is they put the pen up and down. So this is an example. If I say pen down and then move to some random position, it will draw a line. If I say pen up and move to a random position, it will move, but it will not draw a line. And then at the end, when you don't want anything else, you can say erase all. So here, when we start the program, we want to erase all of our drawings, and if we're trying to follow this, then we want the initial position of the pen to be in the middle. So what we would do is set that, and actually if we change the background, this might be helpful. Scratch has a background that shows you where the x and y values are at different points. So the middle of the area is where x is 0 and y is 0 over here. So when we start out, we want to erase all, maybe make sure the pen is up, and then move to 0 and 0, the origin of the scratch stage area. So there we are, there it is in the middle. Then what we'll want to do is we'll want to make 3 lines pointing in 3 different directions. So what we can do, and hopefully this will work out, is we'll say repeat 3, and we'll put the pen down because we're starting here. We will turn. We'll assume that we're initially pointing straight up. So straight up is called 0. Let's actually make that true at the beginning. We'll say point in direction 0. So we're pointing straight up at first. So each time we want to make 3 forks, we will have to draw something to the left, draw something to the center, and draw something to the right, and then we'll want to make sure that we reset the direction back to be pointing in the same direction that it used to be. So we can do that by doing, we'll turn left by some number of degrees, and I think we'll want to be able to adjust this because as we change this angle around, that will effectively give us this animation. And the way to do that is to create a variable. So let's call this angle. We can make it for this sprite only because there's not really any reason. We're going to have only one sprite, but there's not really any reason that we'd need to share it with any other sprite. And it's just in general better to use a local, this is called a locally scoped variable instead of this for all sprites. Checkbox radio button is giving you a global variable. You want to use local variables if you can in general. Makes your code easier to deal with. So we'll turn left by this angle. That will be we'll turn left by some amount here, and we'll draw a line up, and then we'll move back where we were before. So let's actually save the position we're at. So we'll have 2 variables. Save the position. Original x, and we'll make a variable called original y, like that. So we'll save the current version, the current position, set the original x to, we have one here, x position, and we'll also set original y to the y position. This will at least give us the first 3, and then we're going to have to figure out how to keep going. So we'll set these to the original position, and then we'll repeat 3. We'll turn left before we repeat, and then each of the 3 times through, we'll actually turn right. Let me actually save one more thing. Here we'll say original rotation, and we'll make one more copy of this. Original rotation to would be one more here. Direction. I guess we could call it direction instead of rotation, just for consistency. Direction. Perfect. Then, so we'll turn left, we will put the pen down, move by some amount, and that also is going to need to change. So this is the, let's call it the length of the, of branch, because it's a tree, length of the branch. So we'll turn that way, put the pen down, move here, whatever this length of branch is, And we can play with that here by double clicking these variables, and that lets us adjust this. Let's set it to 10, something like that. And then each time through we'll turn right. We'll move, and then we'll need to move back. Go back where we used to be. You might ask, why don't I just turn around 180 degrees and move the same distance again? That is a good question. These numbers are using a numbering system called the IEEE floating point representation. You can look this up if you're ever more interested in it, but one of the properties of this type of number is that they aren't quite exact, and so just based on my experience, I'm a little bit concerned that if we move forward and then move back, that we won't quite end up on the same spot that we started on. Whereas I know that when you store these numbers in a variable, they don't change. So while you might move and move back and you aren't quite at the same spot, but if you save the position in the variable and then jump to that spot, I believe that it's much more likely that you will always end up back where you used to be. So we'll jump back to where we were, except we don't want the pen down during that time, because like I said, you might not quite end up on the same spot, and so you'll end up with a slightly thicker line. I don't know if that's going to look odd or not. So we move and then we jump back, and then we will need to rotate 15 degrees. So let's try this out. Hopefully what I'm expecting to happen is that this will move, it'll draw a line here, and then draw a line here, and draw a line here. And actually, just to make it a little bit clearer, just temporarily, what we can do is add a weight in here like that. And that way it'll be a little bit easier to see what's going on. We can also add one maybe here after we draw. Let's get rid of some of these variables that are in the way, direction. Well, we can actually maybe just drag them out of the way like this and see what's happening. So it turns and is not going very far. Higher, it'll be easier to see. That draws a direction up. Angle is 0, so it's being very helpful. Okay, so we've discovered two bugs. One is that it's not actually turning left, and if you want to pause the video here and try to think about why that is, please do so now. And if you have come back from that, the reason is this angle here is 0, so the first time is when we turn left here. We're not turning at all, we're just turning 0 degrees. We need to set this to some value. Second bug is that even though the angle was 0, the second two lines did actually turn, and that's because I forgot to use the angle variable here, so I have to drag that in there as well. Now we can try it again. We can see that actually it did turn left and came back to the middle, and then drew it again in the middle, and so it'll come back and draw it again. And it's hard to see that second line in the middle because of the background, so even though it was useful to see where we needed to start, now it is not useful anymore, and we can get rid of it. The other thing that I can see is happening is this pencil is also making things difficult to see. So as cute as it is, we can actually get rid of it. Or instead of just having an empty costume like that, the other thing that may make more sense is to just hide it. And I do not think that affects the pen block, so this should still draw all three lines. There's the first one, and the second one, and hopefully the third one. We can delete this block now. Now that we saw what happened the first time, we should be able to draw it. And there you go. So there is our first branch. Now, what we actually want to have happen is that each time we get to the end here, we want to reduce the amount of the length of each of these branches and do it again. So we want 3 more coming off here, and 3 more coming off here, 3 more coming off here. So what we should do is this block here was all of the code that we needed to draw these 3 lines. We'll put that into a function. Your functions are created in this pink section here called My Blocks. You click Make a Block, and you can say draw 3 draw branches, let's say, and you can click this Run Without Screen Refresh, and what that will do is it'll run the whole function without having to redraw this drawing area. So you can't see what happened during the middle, but the advantage is that it will run faster. I do have some other videos. If you search for FPS, you should find the other videos explaining a little bit more about what's going on there. Especially the second video talks about that in more detail. So we'll create this function and put this code in here, and what that allows us to do is say draw branches, and that will just run the code. And you can actually see it's a little bit subtle, so I don't know if it's going to come up on the video, but when I click the green arrow here, we can also make it bigger, you can actually see the 3 lines drawing. Like the first line draws first, and then you can see the right side and the middle lines blinking a little bit because they are delayed after the first line is drawn. It takes a small number of fractions of a second before those other 2 lines are drawn. But when we move this into this function where we had screen refresh turned off, run without screen refresh turned on, then what happened is when we run the flag, you can't actually see it drawing anymore. So that's what run without screen refresh does. So what we need to have happen is that when we draw branches, what we actually want to have happen is that not only does it draw this first branch, but it keeps going. So after this first branch is drawn here, what we would actually want to do is call draw branches again. If we run this, I do think Scratch is going to crash because it'll draw the first branch here, and then I'll draw branches, which will start drawing the first branch, kind of coming off in this direction, and then that will call draw branches, and it'll keep going around, and eventually it has called draw branches too much, and we'll have what's called Stack Overflow. If you've ever seen that website, stackoverflow.com, I believe it has a bunch of questions and answers about programming, and that's where the name of that website came from, is when this happens. So we need to have something that tells us when to stop calling draw branches over and over again. And one common way to do this is you have input that says how many more layers of this tree do you want to do. So let's call it like remaining layers. Let's call it layers. So we'll pass in some number, like let's say 3. Each time we call this function again, what we'll do is we'll take layers and we'll subtract 1 from it. And that way each successive layer deep into the tree, layers will be a little bit smaller than it was before. And finally, at the end, what we would want to do is say if the layers variable is less than 1, say, or less than some number, doesn't really matter, because just set this one higher. If we did less than 0, we say if the layers value is less than 1, then we're already deep enough in the tree that we don't want to do anything anymore. So in that case, we don't want to do anything. And so actually, what we want to do is say if layers is greater than some amount, then do all this stuff, otherwise do nothing. So let's try that out and see if that works. Oh, that's interesting. That was not what I wanted or expected. So there's another bug here. So what's happening is we are, I think, pointed in the right direction. We've just moved, and we started drawing another branch again. And after that's done, we reset back to the original. Oh, I see what's happening. We only have one copy. This is actually one of the problems of Scratch, is that you do not have local scope for variables. So these original X and original Y, there's one copy of each for the pencil sprite. And so as we, here, let's actually slow this down. That will make it clearer what's going on. So we will, every time we draw, let's wait right after we draw. So we'll set that to 3 seconds. Actually, I think what we can do, there's some kind of input block. Ask what's your name? Each time we draw a line, we'll say, what's your name? So they like hit enter to continue or something like that. So each time we draw, we'll say hit enter to continue, and we can do one step at a time. So the first line draws, and that is here, and then we'll say hit enter to continue. And what will happen is we'll call draw branches again, with layers being one less than it used to be. So we could actually even use this ask block to we could even say the ask block, we'll say like layers is, and we'll even display what the layers variable is. Layers is that. Layers is 3. This is the initial call that we're getting from the flag click block up here. We draw it, and our pencil, let's actually show it. Oh, our pencil is not at all where I thought it would be. Let's actually show the pencil. That is an interesting thing. I think it'll help explain what's going on here. So layers is 3. I think we must have accidentally changed the costume. There we go, there we go. And let's have it, you know what, let's have it rotate the direction it's pointing. Even though that'll be a little bit weird. Point it to the right. Say 90. And we'll want the pencil to be pointing the direction that, yeah, like that. Let's see, is this right? No, it's pointing at the right. I would actually want to rotate it the other way. We'll have the pencil pointing in the direction that the sprite is pointing, so it kind of explains more clearly what's going on. Make sure that the point is pointed at the center here. Oh, there we go. Now, depending on, what do you think is 0? So when the sprite's at 0, the pencil's pointing up, and depending on which way you point the sprite, that's it. So what I'm going to expect is that when we run this, the pencil will be pointing that way. So there we are. It drew the line here, and it's still pointing in this direction, and that's perfect. That's what we want. And now we're going to call draw branches again over here with layers being set to 2, and what will happen is we'll turn to the left by 15 degrees and then draw another line. So it's going to turn a little bit counterclockwise and then draw another line. Let's try that out by hitting enter in here, and that is exactly what happened. It drew a second line, and now layers is 2. And then we'll do it one more time. We'll say enter, and now layers is 1. It did the same thing again. It turned a little bit and then drew. Now layers is still greater than 0, so we will do it one more time. We'll hit enter over here. And then what happened is that it jumped back. Why did it jump back? So layers is no longer greater than 0. So this thing skipped, and now we're out here, and we said go to X, original X, or Y, which are hidden down here. And that would be helpful too. Let's actually stop the program. Original X is 0, and original Y is 0. Like so. So let's actually run through this again. So we can see that part of the problem is that original x and original y are only set up here as well as original direction. And so when we exit out of this line up here, this third one, this third layer, it goes to original x and original y, which are never set, and then turns back to some angle, which is also never set. But the problem is going to be, let's say we put this in here. I can actually show what happens. It might seem like it's going to work, but this is I think not going to work either. And the reason is detached. There we go. So layers 3, 2, 1. And you can see that original x and original y are actually set now. So that's good. So this first one will work. It'll jump back to around this spot over here. And I realized what I could probably do is actually just make this much smaller. There we go. 3 and 2 and 1. So now it should jump back here, which is what we want. Because we had just set it up here. So let's actually try that out. But I do think that there's going to be a problem. So hit enter. Oh, that did not work at all. Which I was not expecting. This is totally not working the way I expected. So original x and original y are set initially. Let's actually... Oh, right. We wouldn't want to set them unless we actually moved. So let's try this again. There. So now we can see that this branch is working. So the problem was we got called. Let me explain again. We're at this point, and if we hit enter again, it calls draw branches with layers is now 1. I wonder if we can see that. Layers. We can't actually see that. Layers is 1. All right, it's saying it up here. So layers is 1, and so then when we call draw branches again, we're calling it with 0. And so this is false. And so before we're setting original x and y in direction to this spot over here, which is not what we want. We want it to jump back over here. So we don't actually want to do these things if layer is set to 0. So now you can see it jumps back and does another line, and jumps back and does another line. But the problem at this point is original x and original y are set to this spot over here. So it's going to jump back and not actually jump back all the way over here, which is what we really wanted it to do. So you can see that it's continuing to build a tree out. And that's kind of a cool effect, but not what we're going for. We can actually, that is just kind of cool in and of itself. So we can run that. We could probably actually change this to 30 and it's going to do something neat. Oh yeah, look at that. That's too many. Let's try 10. Still too many to see what's going on. So that's very actually interesting that as we increase layers, I thought that going from 3 to 10 would not be too much, but as you can see, even maybe just going from 3 to 4 might be a lot. And if we go to 5, it's very complicated very quickly. That's kind of a neat effect. But the problem is because like I said, original x and original y are always set to that latest thing. It's easier to see with 3. Let's do that again. So as, maybe it's even easier to see with 2. What happens is you jump up here to do the first branch, then you do these 3. But now, once these 3 are done, what you want to do is jump back to the beginning to do the next set of branches, and then jump back to the beginning again. And once you overwrite these variables, there's only one copy for all of the pencil. There's not one copy for each time you draw branches. So they just get overwritten each time, and that's why it just keeps moving forward. So I think the trick here is going to be to use the fact that each time you call this function, these pink variables, you can't change them, but they are specific to that one call. So rather than saving these to some local variables over here, what I think will work is we'll say like we'll pass them in. So we'll say original x, original y, and the original direction. And this makes it a little bit harder to call the function. But now we can pass these in, x position and the y position and the direction. And then similarly in this call over here, we'll want to do the same thing, where we'll still pass in layers -1, but we'll pass all these other things in too. So these will now be the new positions because we just moved, like let's say we'd drawn the first branch, we just moved to that new spot, so that's going to be the new original for the next 3 branches. But after we're done, the fact that we pass these in over here to the child call doesn't change the values for these 3. So once this call to draw branches, this recursive call to draw branches is done, then these pink variables will continue to be what they were before. So here we can go to x, at that, and then the original direction over here. And let's clean up this mess. Have some extra blocks that fell off. Oops. Control Z. And then now also angle's fine, length of branch is fine. So this is, I think, what we want. We don't really need these anymore. We can get rid of them, and we should actually just be able to get rid of those variables entirely. Not that one. Original x, y, and original direction. Those are not used anymore. So let's try that and see if it works. So this is a little bit better than before, but not quite what we wanted still. So we wanted to turn, oh, here we're turning, this one want to turn angle degrees. And then at the end, we actually want to reset back to the original direction, that direction. So this is after the repeat, back to the original direction. This may work better. There we go. So as we change the angle, we'll keep changing. One thing that we could do is, instead of having to keep hitting the flag over and over again, we could put this in a forever block and just make sure that we erase everything before we do the drawing. And what that should do, we can get rid of the pencil icon again, the pencil sprite. What that should do is let us be able to change this angle and see what's going on as it changes. This variable slider here does not go up to 120, so increase that. And that's already pretty cool. We can change the length of the branch, and that's kind of neat. So let us now increase this to, let's say, 5, or maybe even, oh, that is a little bit slow, interesting. So let's do something that's still fast enough to be interactive. Ooh. So here is a way to make a tree. Now what we originally wanted was to do this as a Sierpinski triangle here. And I think it will be easier to see if we have one that's not animated, but unfortunately that is not the case here. So let's actually look at one of these to try to figure this out. Let's make this bigger. So the initial length of the first 3 branches is going to be this length here. It'd be nice if I had a pencil to be able to diagram this a bit better. But this is from the middle of the original triangle to the middle of one of the smaller triangles, and the next branch length is going to be the same thing, the middle of the smaller triangle to the middle of its child triangle. It's a very similar distance. Like, in fact, it might be easier to think of it as the middle branches all the way. So if you start from the middle and come up to here, that's the middle of the subtriangle, and then the next branch is going to be you start here and you come out to the middle here. So because this big triangle is effectively twice as tall and twice as wide as its 3 children are. That's a little bit easier to see, I think, if we look at the original. The big triangle is obviously twice as tall as any of the small triangles because it's stacked up 2 of them one on top of each other, and it's twice as wide because if you look at the base here, there's 2 of them next to each other. So because the big triangle is twice as big in all these directions, I believe that would mean that the distance from here to here should be twice the distance of the distance from here to here. Is I think, if you remember your geometry class, there's probably some way to prove it. This is the way I'm thinking about it. Is just a quick guess at this to see if we can just get it right on the first try without having to walk through the proof. So what we want to do is have the length of each of these branches actually get cut in half as we're going through. So what we could do is edit this block again to add yet another input parameter here. So this is going to be the length that we want to length of branch. And what we can do is pass in, we have this variable called length of branch that we can pass in. And now inside the function we can use the parameter that's coming in instead of the variable that's only one of them that's associated with the whole sprite. What that then lets us do is that each of the different heights through the tree, so that these first kind of trunk branches can have a really long length of branch, and then each time through, as we get to the children, what's called the children of the trunk, which are maybe like the big thick branches that you would climb up if you're climbing the tree, and then the children of those, which are the kind of skinnier branches, and then the children of those, which might be the twigs, and then the leaves. Each of those could be half as long as the previous parent generation. So the way that we do that is we say take this length of branch and we divide it by 2, like that, and let's see how that looks. Oh, that looks quite a bit different. And actually, even now, you can kind of see that this looks like the animation that we're looking at over here. Here. As this animation is going through, it kind of had that geometrical portion, which didn't look like that, which is kind of cool. We can still, I think, play with the length of the branch, so I'll change the size of the tree. And then as you change the angle, hopefully, if everything's going to work out, as we get to 120, this will turn into the Sierpinski triangle. And there you go. That is pretty neat. We could, oh, that's interesting. It ran out of space at the top over there. If you found this video helpful or interesting, I would really appreciate it if you could hit the subscribe button on YouTube. That way you will find out about more videos as they come out. Hopefully we'll be exploring many more cool things in Scratch and other programming languages. And hit the thumbs up button on the video, and thank you for watching, and see you next time.